Welcome back, everyone. Today we're going to put together some enemy AI using the nav mesh and our state machine so that we can have enemies detecting the player, chasing, and attacking. We'll talk about how we can make it even more extensible using what might be my favorite programming pattern, the strategy pattern. Towards the end of the video, we're going to talk about importing your own packages and how to import Unity packages like netcode for game objects using code. And of course, there will be Unity tips throughout. Links to all the free assets and resources in the description. Let's get into it. So the first thing to do today is we're going to need the AI navigation package. If you don't have that already imported, just find it here under the Unity registry and install it. Once that's done installing, you'll see it in your project there. And we can jump up to the Windows AI and find the navigation obsolete window. And this is going to allow us to bake a nav mesh. So in here, I'm just going to speed this up just a touch because I'm going to grab all of the little floor objects in my scene. And, if you're doing it on your own and you have a terrain, that'll work too. And they'll have to be marked as navigation static up here in the window. So just grab them all and make sure that's ticked. So once you've got all those meshes or terrains marked as navigation static, you can just come over to the Bake tab and click Bake and then have a look at it, how it looks for you. Now, I can see a few of my edges are a little close. I'm going to change the max slope down to 35 and bake again. And it's also baked some of my water. So I'm going to find those and I'm going to make them not navigation static and bake one more time. Okay. That looks pretty good for me. So I've got a little bit of distance around the edges and can go up to a few little steps. I think that'll work. Now, if you come over here and look in your folders, just for interest's sake, you'll notice that in the same folder as your scene, there's a new folder with the name of your scene, but inside is your nav mesh. So that's where you'll always find it. So it's about time we brought in an enemy, and if you guys don't have any enemies to use yet, I suggest you use something from Dungeon Mason, the same creator as our tiny hero, and I'll put a link to that in the description. There's several free packs here. Each of these creatures has a bunch of animations that are suitable for what we're about to do, and if you feel up to it and you like this style of animation, there are plenty of bundles there to buy. So I'm going to scroll down here and find this spiky turtle, which is one of my favorite ones, and I'll just drag it into the scene here. And let's see, I'll collapse up a few things. So the turtle, I'm going to create an empty object inside of the turtle because I want to keep the position, and I'll just drag it out and then drag the turtle underneath that new object, and I'll call it enemy. And the enemy, of course, I'll just put it down at the bottom, but we're going to turn that into a prefab. So I'll come up to my prefabs folder and drag it in. And then we can make some variants later if we want to. So for the enemy, we need to add a nav mesh agent, of course. And I think I'm going to change some of the settings. We'll just start it a little bit slower. And it doesn't need to be quite as tall. And maybe a little bit wider, 0.7. And then let's also add a sphere collider. And the sphere collider probably has to come out of the floor and be a little bit bigger. So how about a 0.7 and just up just a little bit. Okay, that looks all right. Let's just apply all these overrides to the enemy prefab. So now we can begin writing an enemy script. And I'm just going to open up the player controller and make a script directly from there so I don't have to wait for compile times in the editor. So our enemy is definitely going to have to reference its own nav mesh agent. So let's have a reference here to that, and we'll make a serialized field. And we'll use the self attribute, and that'll come from our open source library that we have in the project. Let's also keep a reference to our animator. We're going to be passing that into our states, and of course we need a state machine. Now the state machine that we're using here is the one we did in the previous video, and I'll have a link to that up here in case you're just joining us now and you're not sure how it works. But in Start, we're going to do all the setup for the state machine. I'm also going to paste in these little helper methods that we also have in our player controller, which is also using a state machine. It'll allow us to make transitions really easily. And then our state machine needs to be updated every update and fixed update. Before we can configure that state machine, we actually need to create some enemy states. So why don't we start with a base state? We'll just call it enemy base state. It will implement the iState interface, and we can move that into its own class. I'm going to implement the missing members as virtual members so we can override the ones that we want when we're creating concrete states. And let's keep a reference in every base state of the enemy and the animator. We'll pass those into the constructor. Let's make this an abstract class. And now let's set up a constructor for this to take in that enemy and animator variables. Let's also, similar to what we did with our player state machine, let's have a crossfade duration so that we can procedurally call animations. And we're going to go take a look at those transitions that are already existing and the animations that are existing on these models. So if we select the enemy and then we go click on the animator, you'll be able to see all the animations already set up here for the demo, and they have all the transitions. Now we want to have a nice clean animator, and what you can do is you could either remove all of the animations and drag in the ones that you want, or alternatively just get them all selected and remove them one by one here. So since I haven't quite decided which ones I want to use at the time I'm recording this, I'm just going to leave them all here with no transitions, but you could just wipe them out. But I think just looking at this, I think we're going to want probably is definitely an attack. This walk forward, run forward, die we'll probably want at some point. You know, you can make it as complicated as you want, really. But let's come back into our code here and let's add hashes for these. So we can have this idle one. It was called idle normal. Let's make sure it's static here. And let Copilot try to fill these in as it can, but it doesn't know the names, so I'll have to fix them up. Run forward. Let's also make these start with capital letters. So now if I give Copilot some hints here, it'll get the pattern. We'll be very close to it anyways. So this one was called die. I think just die, yeah. Okay, so I'll clean that up, and there we go. We got 5 animations to start with. And let's start creating a concrete state for wandering around. So we'll call it enemy wander state, get it in here, implement its missing member, which is the necessary constructor. And what do we want to pass in? We want it to probably wander around a specific area. So we'll give it a radius, and we're also going to need a reference to its SnapMesh agent so that it can decide whereabouts it wants to go. So let's make sure that the properties we're passing in that aren't going to the base state get saved up in here. You can use IDE tools, and I'm going to do it that way this time, but it is kind of tedious compared to using Copilot. So in the next one, I'll show you how I do it with Copilot. Now, once we get down into our on-enter state, let's make sure, just for our own sanity, let's debug that we've come into the wander state, and let's start our walk hash animation. So to do that, we just call the crossfade method on the animator. Now, every update method, if we have reached our destination, we should find a different point to wander to. So let's put that Boolean check into its own method here. So we can say, if the agent doesn't have a path pending, and if its remaining distance is less than or equal to its stopping distance, and it doesn't have a path, or it has basically stopped moving, it's time to find a new place. So in here, Copilot's just filling all this out. Basically, find a new position within the sphere, add that to our start point, which was what we passed in our original starting position. Then we want to find a point on the nav mesh for that, and we just set the destination of our agent. So now that we've got a state implemented, let's instantiate one of those states here in our enemy. So we've got our wander state, we pass in the variables that we need. And what we'll do just for testing is let's create a func predicate that is always true. So no matter what happens, we're always going back into the wander state, but let's also set it as our initial state. So that's really all you need to do to go into a one-state state machine here. I'm also going to go back into our base state, and wherever we had these exceptions being thrown, we should really just put no comments there. Okay, let's press play and see how our one-state state machine works for wandering around. All right, so he's moving, he's finding different spots, completely ignoring us. Well, he's definitely doing what I asked, although he's not roaming very far. Maybe we can just change the parameters a little bit here. So to handle that, let's come back into the enemy and expose a wander radius here that we can configure, and we'll pass that into the state machine. I think go with 10, maybe a little bit wider than it was. We'll try that out next time we hit the play button. Let's start a new state. Let's have a chase state. Put that into its own class here. So our chase state is also going to need a reference to the navmesh agent because we're going to be moving it around. But it also needs, instead of a wander radius, this one's going to need a target, which in this case is going to be the player. Essentially, you could make it any transform really, but we'll just call it player because that's what we're after. And so this time, as I said, I'll show you how I do this with Copilot. I just declare them and then it's tab completion. It's done. So Copilot also knows essentially what I'm going to do here because this is very similar to the previous state. So on enter, we'll have a debug statement. We'll start the animation. In our update method, let's just always be updating to follow the player. All right, now back in the enemy, we can declare a new state. We'll just call it chase state. Now the chase state's going to have to know about the player, and how are we going to do that? I think a good way to do it is to add another script that we'll just call player detector. So a player detector can just be responsible for finding players in our game. In a moment, we'll make this extensible by implementing the strategy pattern, but first of all, let's define some values that we can use in this player detector. So if we were going to look in a cone in front of the enemy, we should define an angle that'll, kind of define the size of that cone. So I'll put in 60 for now. We should also define some different radiuses. So one would be a big outside radius, which could define the edge of the cone or maybe just a general circle. But we also need an inner one because suppose the player comes up behind the enemy, if they get close enough, the enemy should still know that they're there, even though they're not in the cone. Now, also, we want to run a timer because we don't want to look for this every frame, but just every once in a while. I think 1 is good for now. We can adjust that maybe. Once we've found the player, let's set them in a property so we can grab this player. Now, we've already made a countdown timer in a previous episode in this series, so we're going to use one of those. And then we're going to use the strategy pattern. And so to do that, we'll make a new interface eye detection strategy. All that needs to do is have one method that will execute what are we looking for, who's doing the looking, and we'll pass in a timer to decide can we actually look or are we on cooldown. So let's implement a concrete one of those. Let's start with a cone detection strategy. So first of all, let's implement the missing member, which is the execute method, and then let's define a constructor here. So the constructor should probably take in that detection angle that we defined before, and the large radius, and the smaller inner radius. So we'll store those in the strategy here. And now we can say, if the timer's already running, just bail out. We don't need to do a check. However, if we are going to do a check, let's find the direction to the player. Once we have that, let's figure out the angle. We can just use the vector3 angle method for that using the detector.forward. So now we can say if the player doesn't fall within the cone or the player is not within our outer circle, then it's a false for sure. But we also want to check that they're not inside the inner circle. So let's also check that one. And then if it's made it past all these checks, then we definitely can detect the player. So let's start our timer and return true. Let's write a comment here quickly to explain what's going on in this little calculation. All right. So now we've got our strategy. Let's put it into its own file. Let's come back to our player detector. Now in the start method, let's define our countdown timer. Let's grab our player based on the tag, and let's set our default detection strategy to be the cone strategy, and we'll pass in the variables that it needs. So like all mono behaviors that have a timer in them, we need to tick our timer in the update method. And let's make a public method, can we detect player? And all that's going to do is return is the timer running, which means we've detected the enemy already, or let's call the strategy and find out if we can detect them or not. And let's make another public method here, just so later on, if we're using an enemy factory, we can just set the strategy there as we're creating enemies. Now back in the enemy, we're always going to have a reference to our player. Let's change that to lowercase, and we should just get a reference to it here. Let's make sure this is always on the enemy too. I'll just add it as a required component. Now what we should do next here is add some transitions. So now that we have two states, if we're at the wander state and we want to go to the chase state, let's just call the player detector. Can we detect the player? And that'll be our func predicate. Conversely, if we want to flip back, it should just be the opposite. Now my require component didn't automatically add our player detector because it's already on the game object. So let's just add it here, and then I need on validate to fire. So I'm just going to tweak this wander radius back to 10. That'll get our reference in there. Now, before I forget, let's jump over to the player and make sure the player is tagged as player, and I'm going to apply all those overrides. And that should do it for us. Let's have a look. Okay, so he's immediately chasing me. You can see the chase coming out in the debug log there. Now if I run far enough away, he'll go back into wander. So he's getting a little closer still. Now he's chasing again. Okay, let's try going to the other end here. Yeah, he went back into wander. Let's just stop. I think I'm just going to narrow down these values a little bit because he can see me, pretty far away. I'll take the detection radius, the big one down to 8 and the small one down to 2, I think. Now, just before we make any other changes, I want to show everybody something that maybe not everybody knows about, and that is the undo button. There's an undo history button up here at the top, and if you click it, it'll open up a new panel that you can drag and dock anywhere. This will show you all the different things that have been going on, and if you want to back up at any point here, you just grab somewhere like where I selected the enemy here. Now you see everything with the red bar beside it will be undone. And you can redo at any time. You can just jump around through here. And it just takes a second. And so, if you make a mistake, just, don't forget that's up there. Also, right beside it here, some of you may have noticed I have a selection history. This is a free tool from Staggered Creations you can get on the asset store. Everything that you click in the game from packages, here I'll click on this one. This is the RPG Monster Bundle. I can see it up here in my inspector, and if I click on View and Package Manager, it'll take me right to it. If I want to see where did this animation come from, like Attack 01, where's that from? Oh, that was in the Turtle Shell animator controller, and then I can open it up just like that, right? So, and then you can hit the trash can here if you just want to clear it out if it's getting too clogged up, but it's invaluable for finding things in your project if you have a ton of assets. So it's free. I'll put a link to that in the description. And then I wanted to dump in some gizmos here, and I'm just going to talk about them quick because I already wrote them. I'm not going to type them out, but this is going to draw a cone, and it's going to draw 2 radius based on the values that we've already put in the player detector. So since we've got the values, we can have it all the time. I'll just reload it, and there we go. So you can see the little radius, the cone in front, and the big radius. It still looks pretty big. But having gizmos like this can help you out a lot. So I'm going to leave them in there, and you can take a look at them in the repo if you want to refer to them later. Let's just have a look at it quickly. If we look at it in scene view, you can see him cruising around. He's just doing his wander, right? If he turns around, still can't see me because I'm not in the cone and I'm not in the inner radius. If he turns around there, he's got me. Okay, so he's just going to start chasing me down, and he'll just keep chasing and pushing me along. So what we really need to do next is get an attack state. So let's get that set up. Now, I don't want to be handling this in the state machine because we might want to swap out weapons. We might want to have something else. So I'm going to first, for now, declare a public method on the enemy that's just going to be attack. And let's define a timer in our enemy too. And we can move this into an enemy weapon script or something like that, an enemy attack script later. But for now, let's get a countdown timer so we can have a cooldown on it. And we'll just call it attack timer. We'll have it just 1 second for now. And as you recall, we have to tick all of our timers. So run the tick method on that timer every update. For our enemy attack state, this is going to be very similar to the enemy chase state. So we've got our basic constructor, but let's pass in the navmesh agent, and let's pass in a reference to our player. So we'll define our variables here for the agent and player. I'll just let Copilot fill them in. And then we'll come down here. When we enter the state, let's debug, let's run our animation with crossfade, and during update, let's continue to move towards the player, but also run that attack method. So I'm going to change this one to say attacking because the other one said attack when we go into the state. And now let's declare our state, our attack state, and let's make one more method on our player detector. And that is so we can decide from the player detector, are we actually close enough to attack the player? So we'll define an attack range for that, I think. And that could be something, maybe we could even define that on the enemy or an enemy weapon later, but let's put it here for now. We'll put it pretty close. We'll put it at a 2, I think. And now, when we're defining transitions, we can make func predicates that actually reference that particular method. And so it's almost exactly the same as the chase state. So from the chase state, we can jump into attack state if we can attack the player. And if not, we go back into the chase state. So say the player starts running away, we'll just start chasing them again. So let's let the scripts recompile and go back into play mode. Apologies for the dropped frames. I'm starting to run out of memory a little bit. So there, he's chasing me now. So let's see what he does. Yeah, right away goes into his attack animation. Every second he's attacking and pushing me pretty good. So he's back into wander now and chase and wander. Now, he's set to wander around his spawn point. So he's going to keep moving back this way all the time. So he's going to find me again, of course, and he does. So if I come down to this end, he should just stay in to wander. Oh, I'm not far enough. Anyway, you get the idea. It's definitely working. Let's come out of play mode here. So in the next episode, we're going to handle taking damage from the enemy. We're going to handle collecting collectibles and getting a score, and a couple other little things just to wrap up this series. So for the last few minutes here, I just want to talk a little bit more about the setup tool that we've been working on throughout this series. And if you look here in the My Tools folder, I've now added a package.json file. And all packages that you want to import of your own have to have one of these. Let's just look at it quickly. I'll have a link to the documentation for this in the description, but it basically needs a name, a version, and a couple other things that you define, and then you can import it. Now, if you look down here, I've added a couple more menu items. This first one is install netcode for game objects. Next one, install Unity AI navigation, which we did already. Here's one that'll install some packages from Git. If we come down here, this is the code that I've written to import packages. I'm not going to type it out because it's a little bit more complicated and involved. Essentially, what's going on here is we're going to make a queue of strings of the package names. Then we are going to pull them out one by one and make a request to add the package. Now there's a delegate on the editor application called update, and we're going to attach a method called progress to that. And when our request is completed, we will simply unqueue another one if there is another one and start that one installing. So it'll just run through all the packages that you send them one by one. Now, unfortunately, unlike assets, we can't do it all at once in parallel. So that's why it has to be a little bit more complicated. Now, if we come back into the editor and have a look here, if I go and find this package.json, I can import this package for myself, but you'll see I get an error, and that's because this is in my assets folder. So what you really need to do is move this out into a folder that isn't part of your project, and there you can keep all your setup stuff, all your common tools, all the code that you like to use in every project, and you can just import it that way. And then you can run these setup methods, and you can make a method in here to run multiple ones of these methods at once. So, this is just going to be there in the repository so you can have a look and, customize it as you want, put in a namespace, make it your own. And then once you've got it running, you come over here, you've got your setup menu, and you can do all these things, or, of course, you can add your own methods. And so maybe I'll just run one here for interest's sake, because I don't have all those open source projects in the project quite yet. So yeah, let's fire that one off. So I'm going to speed it up. It takes about 35 seconds to go through all that. Now, it did recompile a bunch of other things. You see, I got some warnings, and I still have the error about being in the assets folder. But if you look up in my package manager, you see I did indeed install the package that I wanted, and the one that I had already installed is still there. That's about it. I encourage you to go and have a look at that code and really make it your own, because it's very useful. Okay, that's a wrap for today. In next week's episode, we're going to add some stats like health and score using a few more programming patterns. Don't forget to like, subscribe if you're so inclined, and hit the bell if you don't want to miss any episodes. Thanks for watching, and I'll see you in the comments below.